Okay, hopefully this is working now. Fingers crossed. I feel like this is working better. Having some technical issues on my end, but hopefully this is working. Okay, can you let me know in the chat? Can you hear me now? Am I coming through? Hopefully. Yay. Okay, fantastic. Great. Apologies for that. It's too difficult. It's a great start, isn't it? It's a great start to this. Okay, so let me just rewind my mind and let's get back to the start. So welcome to this Let's Code series. We are going to be programming Noughts and Crosses game, and we're going to be doing it in an object-oriented way instead of a very functional way, which we did the last Let's Code series. And if you watched along with the last Let's Code series, you will have noticed that anytime we wanted to solve something, we made a function for it. And it got a bit awkward when we were passing variables around, because sometimes it was difficult. You'd have to like pass them through and through and through and through, and it was difficult to keep track of them. And so we're going to approach this in a different way, and it's going to be, hopefully you will appreciate that it will be easier to program along with. We'll be using repl.it as always. This is a nice, easy, accessible place to program. It doesn't matter what device you're on. You can just access it on the internet. And so, but you're more than welcome to use any IDE of your choice. I've created a new repl.it project, so just made Noughts and Crosses, and we are going to be taking this one problem at a time, okay? This is not a 20-minute how-to guide. This is going to be over a series of videos, and we are going to be kind of doing this properly. Now, one big improvement that I'd like to make compared to last time is the addition of a document. So I'm going to add a new file before we write any code. I'm going to add a new file here, and I'm going to call it release notes. Oh, release notes. Let's do underscore. Release notes.md. MD stands for Markdown, and it is a way that you can write in quite a nice looking way. So for instance, if I put a hash and space and then type release notes, it's a bit like HTML, but really simple. Okay, so you can see on the left here, if you've not turned preview on at the top, you can turn preview on and you'll get this little markdown tab on the right. And you can see here that I've got release notes here, and the hash has made it a title, right? And so I'm going to have version 0.1, okay? And right at the end, what we're going to do, I'm going to put two hashes, and this will be a subheading. Right at the end, we will just make a list of all the things that we've put into version 0.1, and we'll keep a list. And I think that'll be a much nicer way of chronicling what we do version to version. What I'm also going to do is I'm going to make a to-do.md, and we're going to pop all of our to-dos in here so that we can plan what we're going to actually do. So I'm going to put a hash to give it the title, to-do list. And I think I can just, I'm not going to do that actually. I'll do an asterisk as a bullet point. And we are going to, what I want to do today is I want to create the game board. Okay, and I'll be very happy if we can do that. So last time with our password manager, we programmed like a little console app and then tried to like jam a graphical user interface into it. What we're going to do this time is we are going to work side by side and build up the graphical the interface as we program the game. Okay, now Noughts and Crosses is a really simple game, and it is a game that I really dislike. But it is a really good programming project because there are rules to the game. There are a definite amount of players, right? It's always got to be two. There are some very clear win conditions, okay? And if we have enough time, we might even be able to program a little artificial intelligence so that you don't have to play against a human, you can play against a computer as well. And the computer will always beat you, which will be great. We can start the AI uprising. Okay, so we've got our to-do list, we've got our release notes, and we've got our main.py here. Okay, so what we're going to do is we're going to start programming our code, and at points here, we're going to kind of look at what we've got and then wrap it up in an object. And when we get to that point, I will start explaining what objects are, okay? But for the time being, we're going to just start with our window, right? We need somewhere for the game board to be. And when I say the game board, what I mean is the kind of hash symbol with the different spots that the user can place a naught or a cross. So we are going to import the Tkinter library because that is the library that we are going to be that's going to allow us to make our kind of graphical user interface. And we're going to import that as TK. We're going to alias it. We're going to say, instead of calling it Tkinter in our code, we're just going to call it TK. I could call this melon or banana. But I'm going to call it TK because it kind of makes sense. I don't want to call it import it as Tkinter. And so we are going to say our window equals tk.tk. And then, .tk. And then we're going to say window.main loop. Now, this is the last line of code that can run in our program. As soon as that runs, that's it. Our program stops. That's the only thing that's going to keep going. It's just going to keep main looping. And then it's going to rely on buttons being pressed in the actual user interface for things to happen, right? And so we've kind of got the beginning and the end of our code right here, right? We make the window, and then we start running the window, and we've got to do a bunch of stuff in between that in order to have this work. Now I'm going to press run here, and it's going to show me my lovely TK window. Now the first thing we can do is say window.title. I believe it's lowercase title, and we are going to say. What we're going to say, noughts and crosses. Okay, lovely stuff. And so if I just run that, great, we've got a title for our window there. Now, what I am wanting to do is have a kind of grid of 9 buttons, right? A 3x3 grid of buttons. And when we press that button, it will let us place a naught or a cross down, okay? We're going to worry about how we decide whether it's a naught or a cross later. Today, we're just going to focus on getting those buttons in a nice grid. So we are going to have ourselves a frame, which we're going to put all of our buttons into, okay? So our frame will equal a tk.frame, and we are going to, the frame is going to be kind of a child of the window, if you like, okay? And now what we're going to do is we're going to add all of our buttons to that frame. And then right at the end, we're going to say frame.grid, and we're going to pop our frame into the window. We're going to say row 0, column 0, and we're going to say sticky equals, so I've done quite a bit of like looking into Tkinter and playing with it. And I've definitely got better at it, but I'm still not. I like sticky means like what side of the window does it stick to, right? North, east, south, southwest. But that's kind of so you can use it to kind of stick things over there or up there, depending on where you want them. And if you want them stuck to all sides, then you just do north, east, west, south, and news, and that's all fine. So we're going to stick to that, and we're not really going to use the sticky aside from that in this. Okay, so we've got our frame. Now we need to start adding buttons. Okay, now our buttons, they're going to be a grid in our noughts and crosses, right? It's going to be one of the 9 spaces where a player can put his or her go, right? And they're all going to be the same, right? They're just going to be in a different position. And instead of kind of writing button 1 equals tk.button and doing this 9 times, we're going to be slightly cleverer about it. And also what we're going to do is we're going to think about how we can encapsulate what it is to be a space on the board, okay? And this is where our objects and our classes are going to come in, and how the kind of real thrust of how we're going to be programming throughout this series is kind of go down. So I'm going to, up here, we will move this into a new file later, but I'm not going to move it right now. I'm going to create a class, and a class is a bit like a cookie cutter, right? And I can chop out exactly the same thing with my cookie cutter. So I'm going to say a class of space. Now, class names always have a capital letter. And we are going to just put a colon at the end there and then drop down onto a new line. And then we're going to do we're going to say def underscore underscore init underscore underscore, and then brackets, and we're going to pop self in these brackets. Now, you probably aren't sick of the word self yet, but you will be by the end of this series. When we're working with classes, self refers to this instance of the class. And I'm going to show you kind of how this is going to work. It's going to seem a bit abstract at the moment, but hopefully it will start to make sense. So when we make our space, we need to know what row it's in and what column it's in. And we are going to say self dot, and we're going to say blank char. So the blank character, if there's not a naught or not a cross in it, what's going to be the character inside it? Is it just going to be empty, or is there going to be like a line or something? So we're going to say self.blankchar equals, I'm just going to put a dash for now, okay? We are going to say self.button equals, and then we're going to say tk.button, and we're going to create a new button in here. When we create a space, it creates a button. Now, what we need is the parent. We need the frame to put the button into. So this frame here, when we make our space, we need to tell it that the button that we're going to create with our space, it actually belongs inside that frame. And so we're also going to give it a parent here. So parent, row, and column. So when we initialize a space, we want to be told the parent, the row, and the column that it's going into. And then we're going to make our button. So we're going to say parent. We are going to say, what we're going to say? We're going to say, up here, we're going to pop in a self.contents. And we're going to set that equal to self.blankchar to begin with. Okay, so when we first start and make our grid, all the spaces are going to be empty because no one's played our game yet. And so actually what we want to do is we want to say self.contents equals tk.stringvar. Now, stringvar is a really important concept that I kind of didn't manage to fully wrap my head around when we were doing the password manager. And this allows us to have things like labels and buttons be able to update what's inside them once our app is running, okay? And they're really helpful. So self.contents equals tk.stringvar, and that's going to create us a variable that Takinta can use and that we can change and it will update in real time. We're then going to say self.contents.set. So we're going to set our stringvar, and we're going to set it to, self.blankchar. Now, I could obviously just put this in that bracket rather than putting self.blankchar, but I want to keep this consistent. I want so that I can change it in one place if I wanted to change what our blank character is, maybe just a space, maybe an empty string, maybe two equal signs, whatever I wanted, maybe a plus. That would be confusing. And everywhere else, I'm just going to reference it by this. And you can see that blankchar is in capitals because it is a constant, okay? It's never going to change throughout the program. A blank character will always be the same symbol as the program runs. One game's not going to be different to the next game unless you were to close the app, change the code, and then run it again. So we've got our button. So we are going to say our text variable equals self.contents. And we also need a command. Now, at the moment, we're going to just do nothing, okay? So I don't know. I'm just going to say print, okay? And it will just print a line in the console, and we'll be able to see that it does something. Now we've got ourselves a space, okay? And we're telling the space how it should initialize, okay? It's going to create itself a button using the parent that we give it. We also need to put the button into its parent. So we're going to say self.button.grid, and we're going to say the row of the button equals the row. So this row here that we've been passed in. We're going to say the column equals the column that we've been passed in. Okay, and that's all fine. Okay, so now what we're going to do is we're going to come outside of our class of space, and later on we might come back to this and add some more kind of functionality to this class, but we've defined what it is to be a space on the game board, one single space, and we're going to need 9 of these. Okay, it's going to have a contents, and so we might update that to a naught or a cross later on. Yeah, it's also got a button, and so we can access the contents of that button really nice and easily by doing something like this. We can say space equals space. Okay, and this will create us a brand new version of this. And then I can say space.contents, and it will be whatever I have set this to. At the moment, I've set it to self.blankchar. And so self.contents, if I said space.contents, it would equal this here. Okay, now we need to make 9 of these, and we're going to do this using a loop. So we are going to say for I in range 3. Also, I think maybe we should set a constant. It's a little bit over the top, but I'm just going to come up here and I'm going to say board size equals 3. Okay, and then whenever I want to talk about the number 3, I'm just going to say board size. Okay, so and instead of I, what I'm going to do is I'm going to do, because I is going to be going down. So we're going to say for y in range. Okay, so we're going to think of this in x, y coordinates. So our y coordinate going down the page, and then we're going to say for x in range, board size. And so we're going to go to y. Y is going to be 0 to begin with, so we're going to be right at the top of the board. And then x is going to be 0, and then x is going to be 1, and y is going to stay 0. Then x is going to be 2, and y is going to stay 0. And then that loop's going to end. Y is going to become 1 and come down. X is going to be 0, and then x is going to be 1. Then x is going to be 2, and then the loop's going to finish. And then y is going to go to 3, and it's going to do that loop again. So x will be 0, then x will be 1, then x will be 2. And we'll have ourselves a nice grid using xy coordinates without having to do much complicated things. So space equals space. Now we need to give space, when we initialize it, we need to give it some information. We need to give it a parent, a row, and a column. We've defined that. So our parent is going to be the frame. Our row is going to be our y coordinate. So we're going to give it the y coordinate. And our column is going to be our x coordinate. So we're going to give it the x coordinate. And this is going to create ourselves a brand new space. Now we need to contain this somewhere. We need to store it somewhere. And so what we're going to do is we're going to add this to an array. Okay. So what we're going to do is we are going to create an array called spaces. And we're going to set that to an empty array. And then every time we make a new space, so this here is making a brand new space on our game board, we are going to say spaces.append space. I'm sick of that word already. Space. Okay. Didn't want to space. Yeah. Spaces.append space. We're going to add that to our array, and this array is going to fill up with all 9 of our spaces. Okay. Our frame. These spaces, when they're created, they're added to our row. We're giving it the parent of the frame. Okay. And then in the frame is being added to the window, and so this should just work. This should just work, okay? We've defined what a space is. We've told it what it needs to do. It needs to make a button. And so now if I run this, look at this. It worked. And you're probably like, why? What have I just done? If you're not used to programming in an object-oriented way, it's a little bit odd. But an object, essentially, like the space here, it holds state. So it holds the state of what its current character is. Okay. And actually, let's do an example. Let's do an example of how these objects might work. So down here, inside space, just underneath our initialize function here, I'm going to write a new function. Now, if it's a class, if I'm working inside a class and I have a function, okay, we refer to these as methods. I might refer to them as functions a little bit, but these are, strictly speaking, these are called methods. So we're going to create a method here, just a function that belongs to a class, and we're going to call it set contents. Okay. And we need to put self inside these brackets. Okay. And what we're going to do is we're going to say self.contents.set, and we're going to set it with just an X, okay, just to show you that kind of this working in some kind of context. And now what we're going to do is up here with our command, rather than saying print, at the moment you can see the line on my console here, it is printing when I click a button, okay? We're going to change this to self.set contents. Now, for my method names, well, let's get rid of this. For my method names, I am using a thing called lower camel case. Okay, so the first word of my method is a lowercase letter, and then all subsequent words are uppercase letters. All of my variable names will be pothole case. So if there are more than one word, which there aren't at the moment, but if there was, it would be an underscore and then the next word. Okay, so that's pothole case, and our classes are upper camel case, so always starting with an uppercase letter. Just a little bit of a convention there. And obviously our constants are all in capital letters to show that they are constants. So we're going to say set our self's contents to an X. Okay, so we've made this nice little function, set contents, and then we're saying the command when we click the button is self.setContents. So now if I stop this and run it again, we should see that whenever I click a button, it changes to an X, and it gets slightly bigger because an X is apparently bigger than a dash. And you can see here that each individual button has its own method. It's talking about itself, okay? And that's what this self is. It's, if I run this again and click this button, it's talking about this particular button. You're going to set this particular button's contents, right? We're not going to set any of the other spaces. We're going to leave them, but this self, this myself, I'm going to change my contents. And this is the real power of classes and object-oriented programming, is that we can hold a lot of state, and it makes it a lot easier to program in. I hope I haven't I haven't labored the point too much there. I'm trying to strike a balance between not being too dull and not just glossing over everything. Okay, obviously this is a terrible thing to do. I can't just set X to everything, but this is kind of a good proof of concept. This is working. What would be nice is to have a width of our button. So we're going to say self.width. Actually, they need to be squares, don't they? So we're not going to say width. We're going to say size. Okay, and we're going to set that equal to like 10. Okay, and then when we make our button, we're going to say width equals self.size, and you'll notice that I've done size in capitals because it's not gonna, the buttons aren't gonna like be shrinking and expanding throughout a program. They're just gonna stay one set size. I'm gonna say the height equals self.size, so we get ourselves a nice square. And now I can stop this and run it. Okay, this is too big. Also, height in Tkinter seems to be double whatever the width is, which is go figure. So let's keep this at 10, but the height, instead of saying self.size, I'm going to say self.size over 2. And for some reason, that should just work. No, didn't like that. Oh, okay, but it has to be an integer as well. So I'm going to wrap that as an integer. And so we're going to say the height equals, because whenever we divide in Python, it returns a float. It does, even though it's 5.0, Tkinter doesn't like it if we try and make a height with a float. Let's run this, okay? And you can see these are more or less square compared to what we had. I don't know why I have to divide the height by 2. There we go. There we have it. Okay, we've got the game board. Okay, this is our game board here. This is all of our spaces. Now, what we're going to do is we're going to encapsulate this game board inside another class. Okay, so we're going to take the code that we've got here, and we are going to pop it inside a class. So we're going to say class game board. Okay, you can see that for each word I've got a capital letter because it's a class game board. And we are going to define an initialize function. So def underscore init. Oh, sorry, the inner hooligan in me came out then. And we need to give ourselves the self. The self, so important. When we make the game board, we need to have the window. So we need to be given the parent of the game board, the window, so we know what to attach the game board to. And now what we're going to do is we're going to kind of take things that are down here and we're going to see whether they belong down here or whether they belong in the game board. Now the board size, that's relevant to the game board, right? That's the whole, that's like game board 101. So we're going to put board size in here, and of course we're going to prepend self dot to it. So we're going to say self dot board size equals 3. Okay, so whenever we make a game board, we're going to say that the board size, the size of this board is 3. We're then going to say we're going to keep our spaces in a array. So we're going to go say self dot spaces, and we're going to pop those in here. And now we've got this bit of code here which creates all the spaces. Okay. Now what I'd quite like to do is I'd like to make a method that just does this for us. Okay. So we're going to say def create spaces, and we need to include the self in these brackets. I will forget that at some point and it will drive me mad, but I'm managing to remember it so far. And we're going to pop this code in here, and it's not going to indent it for me, so I'm just going to push that along. So we can see here that I've got my initialize function in my game board, and I've also got my create spaces function method. And we can see here that it's underlining board size. Because board size doesn't exist anymore, self.board size is all the rage now. So we're just going to update these to be self.board size because they belong to this class now. Okay, this value here, this variable. Okay, this property. So space equals space, and instead of we do want to take this frame, we're going to pop that in here actually. I guess really what we should do is we should say create board. Let's say create board. I think that makes more sense. Now down here, spaces.append space, this should be self.spaces as well now. Okay, so we've got our list of spaces that we're going to keep them all in, and we're going to pop all of our spaces into that self.spaces. Now when we create the board, we need the frame to put this in. So we're going to take this line here and we're going to pop it up into create board. And we also need to put that frame into a grid. So we're going to take this line here and we're going to pop this down here. Okay. So once we've got our frame, we're going to actually we could probably say, what could we say? We could probably say self.board. Self.board equals tk.frame, and we're going to be passed in the window. Okay, we're going to give it here the window. So we're going to, instead of saying frame.grid down here, we're going to say self.board. And then we need to update this here, space, instead of frame here, we're going to say self.board. Okay, so we're storing self.board. And up here, I could just remind myself that self.board exists by saying self.board equals like an empty string or something, just to remind myself. And then, and then we're going to say, say self.create board, and we're going to give it the window. So down here in the definition in the method, I'm going to give it a window, and then up here, I'm going to say window. Now you will notice that here in create board, I'm asking for two things. I'm asking for the self and for the window. But here, when I call the method, when I actually use it and say, okay, now it's time to create the board, I'm only passing in the window. And that's because self has to be the first thing, but it's like a behind the scenes thing as well. You kind of put it in the definition, but then you don't have to like pass in self. Just go with it. Just try not to think about it too much. That's what I do. It's much easier, simple life. So we pass in the self and we pass in the window. Okay, we pass in the window when we create the game board. We create the board and we use this method to create the board. Okay, we make the board stored in self.board. You getting sick of me saying board yet? We do this loop that we did earlier. Okay, we know this works. We create spaces that are linked to our self.board. We add those all in, and then we pop this board on the grid. Okay, so now what we've got down here, if I'm to close these classes up, we've got a window. Okay, we say window equals tk.tk, and you'll notice. Well, we'll stick a pin in that. Actually, you won't notice just yet. But let's now let's say gameboard, and I'm going to do this in pothole case because it's a variable. Okay, I'm going to say gameboard equals gameboard. Okay, and we're going to create a new instance of this class. So we're going to go bosh. Here's a new instance of the class. When we initialize the gameboard, so when we first create it, we have self, but we don't need to give it that. But we do need to give it the window. And so we've created the window down here, window equals tk.tk. So we're going to pass into the brackets here the window. And then it's going to, so whenever you create it, it runs the initialize function. You don't need to tell it to run the initialize. This is what it does automatically. As soon as I say this, gameboard, it will do this. It will do this function. Okay, so it will set its board size to 3. It will create an empty array called self.spaces. It will create an empty string attached to self.board, and then it will run this method self.createBoard and pass in the window that we passed in, which we passed in here, which we created up here, and that will create us our game board. Okay, and this should just work. This should just be fine. And you'll notice here, you can see tk.tk. This is creating a new. This is a class, right? TK that they've implemented, and they can say things like window.title, and this title is a method, right? It's got brackets in it, and just like create board is a method up here, and we give it the window. Title is a method, and we give it a string, and what that does is it pops up here, gives it a title on the top of the banner. Okay, so that's a class in action that we kind of just are using. And as you start looking into more and more programming, you will notice that everything is just an object. Everything is a class. And I'm going to use the word class and object like interchangeably. Class is like a definition, and then object is kind of like when you've got the class, when you've created a new instance of the class. So we've now got 4 lines of code that is our actual program here. We make our window, we make our game board, and then we run our window. So I should be able to just run this, and it should look exactly the same and function exactly the same. I can still click these, and they turn into X's, okay? And everything is dandy. And we have 2 classes here, a game board and a space. Now, this is really helpful because if I wanted to reset the game board, I could literally just, at some point later on in my code, I could just say game board equals game board and just create a brand new game board. And it would just get rid of what we had, and it would just pull in, it would just redo everything. It would go through this, it would reinitialize, and everything would kind of start afresh, start anew. And so this is a really nice and a powerful way to program here. Okay, this is great. So we've got ourselves a game board, and I'm getting sick of saying that word. So what's our to-do list? Create a game board. Huzzah! Fantastic. So let's think of what we want to do next. So the next step really is to get our player information. So we're going to add player information at the top of the screen. So at the top, I want to know whose go it is, who the players are, player 1 and player 2. I want to know who's noughts, who's crosses. I want to know who's won how many, who's drawn, who's how many like they've lost. I want all this information. So we're going to do that tomorrow or next version, whatever you're, however you're kind of working through these. So version 0.1, we created the game board, made a space class and a game board class. Okay, and if we just have a look down here, that's made a space class, made a game board class. Okay, fantastic. And this is where we're going to wrap it up today. So it feels like we haven't done a lot, but I promise you we've laid in a lot of groundwork here to be able to develop this quite quickly as we go forwards. Okay, and you can see now that by kind of wrapping all this code up inside these classes, just makes our code so much cleaner and so much nicer. And it should be a much more pleasant programming experience as we go through this, because once you get your head around the object-oriented style of programming, this class-based style, things will start just to click, and it should just work. It should just make sense. As always, thank you so much for watching and following along, and I really hope to see you in the next version tomorrow at 6 o'clock, when we will be continuing with this and developing it even further. I hope to see you then. Take care.